Okay, so you have your piece of paper, yes? I need a portrait, not landscape. I need a portrait. Would you put a portrait on your desk, please? I want you to fold it in half. Guys, I was very clear that it's not landscape, it's portrait. And then we folded it in half, portrait. Yes? Now, here's what I need you to do. Are you watching? Oh, no. I was very clear. I even showed you if you were looking, right? Okay. I need you to take this front and I need you to fold it over, but not real far. Maybe like an inch. So see, it's kind of like that. Does that make sense? And then I'm going to put staples. Like that. You see where the staples are? They don't go right up to the fold, but they're on that side where the fold is. Here. Good job. Yep, that's where I have mine. One's right here, one's right here, one's right here. You can put 2 staples if you want. You can put 4 staples if you want. I've got 3. Any more than that's kind of overkill. Guys, enough. Enough. Any more than that is overkill. Okay? Stapler's coming around. Okay, the next part, I'm going to take mine and I'm going to turn it this way. Okay? There needs to be 5 sections on this. Now, for some of you, that's going to really, really, really annoy you because there's not really a way to measure to have 5 equal sections. You just kind of got to guess. You got to make 4 cuts so that there are 5 equalish sections, and you're only cutting to the fold. Does that make sense? You're only cutting to the fold. Does everybody understand what I need you to do? Yours doesn't have to be stapled before you can make your cuts. So if you're waiting for the stapler, you can go ahead and make your cuts. Just the top. That's why I've been showing you just the top. See how the bottom is one whole piece? Just the top is cut. Okay? Yep. You're going to make 4 cuts, which will be 5 sections. How close are we to being done? Yeah, some people were arguing earlier whether this was a foldable or a stapleable. I'm like, we folded it. They're like, yeah, but we stapled it too. I'm like, you've been away from school. It could be a cuttable. Yeah. I said, you've been away from me for too long. Okay. And up at the top here where the staples are, above that folded area, I wrote solving quadratics. I've been trying to patiently wait for you to finish yours, so I drew some things too. But solving quadratics is what we want up there. Okay? Shh. Everybody ready? You have your 5 cuts on your top page and you have solving quadratics here. Okay, I'm going to turn it sideways then. Back to portrait, and I'm going to zoom in. In. I said in. What was the very first way we learned how to solve quadratics? The very first way. Graphing. Okay? Now, go with me real quick. Walk through this with me real quick. How do we solve a quadratic by graphing it? Don't say we graph it, because I know that, but what are we looking for when we graph it? The x-intercepts. It's where across the x-axis, right? So how are we going to look at a problem and know to solve it by graphing? Well, the first indication is if it tells you to solve it by graphing. If it tells you to solve it by graphing, you should solve it by graphing. Yes, that's a good idea. Okay. When is another good indication that you should solve it by graphing? When there is a graph. When there's a graph with it, that's a good indication that they want you to solve it by graphing. Now, it could just be that they put a graph there, or I put a graph there in case you wanted to use the graph, right? Is there only one way to solve every quadratic? No. Okay? What we're trying to figure out is what are the best ways? Like, when are the best times to use graphing? Okay? One more thing, one more good indication that you solve by graphing. Nope, move back. When it's y equals. Okay? What are all the other ones going to probably, not square roots, but what are all the other ones going to want to be equal to? 0, right? If there's an x and a y, that's a really good indication that you should solve it by graphing. Okay? Got it? What's the next way we learned how to solve quadratics? I just said it a second ago, by the way. Square roots. How are we going to know by looking at a quadratic if we should solve it with square roots? First indication that we should solve it by square roots is it says to solve it by square roots, right? But what if it doesn't say? How are we going to know to solve it with square roots? What do you mean by that? So if there's already a square root in the problem, you think that we would want to solve it by square roots? Hopefully there's not a square root in the problem already. We're usually the one that put the square root sign in there, right? When do we know to put the square root in there? When it's x squared equals, right? X squared equals a number. So if it's x squared equals a number, what's there not? What's missing from the problem? An x. Okay? So when there is no x, no x term, or another way to say it is b equals 0. Okay? Square roots is the only one that we don't want to get equal to 0, do we? We don't want it something, something, something equals 0. We need it x squared equals everything else. Because once we get x squared equals everything else, then we can square root both sides. And what are we always going to start with on the right-hand side then, or on the side opposite the x? Plus or minus, right? Because anytime we take the square root, we could have the positive option or the negative option, right? Okay. What's the next way we learned how to solve quadratics? Yep. Factoring. How are we going to know how to solve, when are we going to know what to solve it by factoring? When it says the other way we're going to know to solve it by factoring is when the quadratic can be factored. We're going to look at it with our eyes and we're going to think, what two numbers multiply to be AC and add to be B? If that's something we can come up with pretty quick, we should factor it. That's going to be the quickest way, right? Any questions about that? Are we okay with the first three so far? Okay. What's the fourth way we learned how to solve quadratics? Completing the square. Now I'll give you a hint on this one. 1, 2, 3, 4. 4 things that we want to look for. Okay. First of all, how are we going to know when to solve it by completing the square? When it says when we complete the square, what's the very first thing we have to do? X squared has to be by itself, so A has to be what? 1, right? There can't be any A besides 1. So if there's a number in front of the x squared, I have to divide everything by that. That creates fractions most of the time in every other place, doesn't it? I don't want to have to deal with fractions if I don't have to. And if I'm trying to figure out the fastest way to solve a quadratic, and I try completing the square, the first thing I want to make sure is that A is 1. The next thing I want to make sure of is something about B. What are we going to have to do with B? Divide it by 2 and square it, right? Well, if I'm going to have to divide it by 2 to avoid any fractional numbers that I have to take care of, then I want to make sure that B is even. I'm not saying I can't do completing the square if it's not even. I'm saying I'm trying to find the fastest way to do these things, right? And the last way is when B and C are smaller numbers. Sure, I can do it if B and C are bigger numbers, but there might be a faster way if B and C are bigger. So I want B and C to be smaller. Now, what do I mean by smaller? Is 24 smaller? Yeah. Is 100 smaller? Maybe. Probably not 1,000 though, right? The word small is relative. You know that, right? Relative to what other numbers are around it. Okay? All right. Ready for the last way? What's the last way? Do you know the quadratic formula? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that was really, really sad. It's been a while since we've sung it together, so maybe you've forgotten it, so we should probably do it again. Okay, ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What is it for? Solving quadratics, right? Now, earlier when I said what's it for, they said, oh, it's the quadratic formula. No, 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 I'm not asking what it's called. I'm asking what it's for, right? It's for solving quadratics. It's the quadratic formula. How are we going to know when to use it? When it says, whenever I want to. Gosh. Why? It always works. Is it always the fastest? No, but it always works. Okay? It's not always the fastest, but it always works. Got it? When can you use this foldable? Notes, quizzes, tests, homework? If, take care of it.